Okay, guys, today I'm going to explain a little thing about my digital assignment. My name is FISEHA TADDESE and my register number is 18BEC2026. And for my digital assignment, I selected the journal paper, which is an area efficient floating point addition unit with error detection logic. This is the journal paper that I selected for my digital assignment. Now let's jump right to the questions. The first question: explain how the selected paper related to COA syllabus or curriculum. So the connection between the journal paper that I selected and the course that I'm taking right now is the numerical competition involving the floating point operands is fundamental in many scientific application because of the high dynamic range and good precision. Floating point operations are used in several fields like sine, exponent, mantissa are the three values by which the real number is represented in standard floating point formats. That's the little description about the floating point addition, and this paper is related with the COA syllabus or curriculum in the following ways. The first one is the floating point operation. The floating point operations which we are learned in our syllabus are also mentioned in this journal paper. And the second point is floating point arithmetics, and including the other arithmetic operations also mentioned here, and some of the components which are involved for the float point addition are also mentioned here, and numerical computation involving floating point operands and general floating point addition with a leading zero anticipator, which is described in the figure below. So this diagram represented the leading zero anticipator float pointing addition method, and that also have a connection with our COA syllabus or curriculum. As you can see, this diagram contains multiplexers and add-in, subtraction, and shifters and different kind of things. And I draw this diagram using a diagram tool called Drawing IO. This diagram tool is very cool and it's very easy to use. As you can see, you can drag and drop some different kind of shape to represent some processes and also to represent outputs or to represent inputs. So it is much easier to draw your diagram as well as your charts or any kind of representations. When we get to the next question, it says draw the existing architecture discussed in the paper using the appropriate raster graphics editor. So what kind of architecture is mentioned in the proposed journal in the selected journal paper? So these are the two architectures which are mentioned in the selected journal paper. They contain some adder and leading zero anticipator, which goes into the shifter, and that shifter is going to compensator, and that compensator leads to output. So in order to perform a float pointing addition, this kind of process will be followed, and this the same process will be followed when there is a carry around. We follow this kind of method. I just put some little description down here. The first figure represents there is an error correction using a compensator select, and figure B shows us it's an error correction using carry. Okay, when we go to the next question, draw the tabulated result and graphs which are existed in the selected journal paper. So the first one is existing and modified carry selector adder. So one of the data collected in the journal paper is existing and modified carry selector adder, or we can call it for short as CSLA. Generally consists of two ripple carry adders and a multiplicator. And when we see about its components, it contains XOR and 2 1 max or multiplexer, half adder and full adder. And they have their own delays, as you can see, 3 3 and 6. Area count, you know that in float point addition, area and power are the most crucial things to consider. So that's why we are considering area count here, and each and every component have their own area counts. And the another data that we collect from I collect from the journal paper is the comparison of area, power, and delay of different architecture. So what kind of architecture are mentioned in the journal paper which are put for comparison? So there are actually 3 architectures that are mentioned in the journal paper, and there are some points which are put for comparison. The first one is number of 4 input LUT, occupied slice, delays, and total on chip power. So based on these points, we are going to compare the given architectures, or the given proposed architectures in the journal paper. So the general floating points, actually it requires 703.854. It goes for the floating point using leading zero anticipator method, and the proposed architecture will have 716 number of 4 input LUTs, occupied slice. As you can see, for every listed points have their own values. I think and later I'm going to explain each and every data. So the next question: draw the proposed architecture discussed in the paper using diagramming and vector graphics application. Okay, and the proposed architecture with the leading zero anticipator. The proposed architecture which is mentioned in the journal paper include a leading zero anticipator and an error detection logic. Make a use of modified carry selected adder. So it contains two significant parts. One is the leading zero anticipator, and the next one is a carry selector adder. And among the various error detection logics, the ones that use a carry select circuit check for carry at a leading digits position and detect the error in leading zero anticipator output is chosen for modification. So between the two components, which are the leading zero anticipator and the error detection logic, the output which we get from the leading zero anticipator will be chosen for modification. So after modification, so it goes for the correct answer. As you can see, it is mentioned in the given diagram. So the next question is draw the transistor level internal diagrams. So what are the transistor level diagrams exist in the given proposed architecture? So the first one is the efficient single precision floating point addition unit is implemented in VHDL language, and it's simulated using Model Sim. We know that Model Sim is a good software for simulating some logic circuits, and the VDHL code is verified using MATLAB. And as you can see, this is the output from the Model Sim that we use to run the data. Now compare the proposed architecture with the existing architecture in reference book. As I mentioned earlier, there are 3 types of float point addition which are put up for comparison in the given journal paper, which are namely they are general floating unit, float point using leading zero anticipator, and we have the proposed architecture. As you can see, the data shows the occupied slicing in terms of general floating point is 367, in float point using LZA is 471, and in the proposed architecture it's around 415. So delays in terms of the general floating point unit is 64.93, 31.98 it will be in terms of floating point using LZA, and proposed architecture will be around 39.5. Actually, there are a difference between the given numbers. I will be explaining about different numbers and their uses under the demerit and merits of the proposed architecture. So list the advantage of the proposed design over the existing design. So what makes better the proposed design over the existing design? So what are the advantage? For mentioning the advantage, the first one, efficient single precision floating point addition unit. So there will be an efficient single precision floating point addition will be here during this in this proposed architecture. And next, the compared result shows that the architecture using LZA is efficient in terms of delay. Actually, if you see in this tabulation, if we see the proposed architecture delays is around 39.5, which is better than the general floating point unit. So next is the next one, compare using the general structure, it has reduced delay, we already mentioned that. And the proposed architecture is an efficient architecture in terms of delay and area, not only in terms of delay but also in terms of area. The proposed architecture has a better advantage for performing a float point addition. So, and it also a good alternative for other implementation for many data processing processors to perform fast arithmetic function, as well as the proposed architecture is very good for performing fast arithmetic functions. So what are the merits and the demerits of the proposed techniques over the existing techniques? So when we see the merits, it's efficient in single precision floating point addition unit. And one of the demerits is the proposed architecture has a reduced area and power compared to the architecture using LZA with a slight increase in delay. Actually, one of the demerits of the proposed architecture, it has you can see right here, when we compare the proposed architecture with the float point using LZA, it has a little bit more delay, and also in number of slices also it will be a little bit less, which make him a little bit slower. And the next one, it has a reduced delay. Yeah, the proposed architecture has a reduced delay. And error detection logic, one of the demerits is error detection logic helps to reduce the delay of the general floating point but are not area efficient. This means it is actually good for reduce the time, but when we compare it in terms of area, it has a little limitation. And the another merit include an efficient architecture is in terms of delay and area, and good alternative for other implementation for many data processing to perform fast arithmetic functions. We can say that it performs fast arithmetic function rather than the other architecture. So next question, list the application of the proposed design. What are the applications of the proposed design? It is an efficient approach to reduce the area and the power of the float point addition. So the first and the most application of this proposed design is that it has an efficient approach to reduce the area and the power of the float point addition. And next, detects error in float point arithmetic, provide an area efficient float point addition unit with error detection logic unit. And last one, since the single precision area efficient floating point addition unit is designed using an efficient carry select adder together with error detection logic, it plays a great role in floating point addition. And last question is, draw the flowchart or the algorithm or the transistor level circuit proposed in the design. So this is the transistor level circuit which contains around 1, 2, 3, 4, 5, 6, and 7. It contains 7 ripple carry adders, and we have 3 multiplexers, and we have an input C in right here, we have an C out here. And this transistor level circuit is called 16-bit conventional carry selector adder. This is all about my explanation about my digital assignment and the journal paper I selected. Thank you for listening.